Hello viewers on YouTube. In this video story, we are going to talk about the sum of a geometric progression. Now, the sum of a geometric progression is simply split into two. Sometimes we might need to find the sum to infinity of a GP. Well, this can only be possible if the GP you are having is a kind of GP whereby its common ratio is less than 1. Otherwise, to get the sum to infinity might be a little bit tricky. So what are we saying next sense? Let's begin with the formulas you have to be familiar with. So the sum of GP is represented as S of n. It carries two formulas which depend on the value of the common ratio. When the common ratio is greater than 1, then the sum of that GP would be in this form. The first term multiplied by r raised to the power of n minus 1, and entirely divided by r minus 1. Now, be careful, there's difference between r raised to the power of n minus 1 and r raised to the power of n minus 1. As some students, those sometimes made this kind of mistake. You do r raised to the power of n first, and then subtract 1 from your answer. Not that you will do n minus 1 first, then you will now raise r to that power. Don't do that. Okay? Perfect. Now for the second case, the sum of the GP would be when r is less than 1. So that's given us a multiplied by. Now the only difference is that the position of this r raised to the power of n and minus 1 will changes. So 1 will be coming first, minus r raised to the power of n. And if it applies to the denominator, it will be 1 minus r. So those are the two formulas. For you to know which to use and when to use, that will depend on the value of r. So when your common ratio is greater than 1, this is the best one to use. And when your common ratio is less than 1, this is the best one to use. Now, before we begin going over some examples, let's talk about the formula for sum to infinity. Now, when we have a series, typically a geometric series, where the common ratio is less than 1, and this series tends to be an infinite series, we can still find its sum. Okay, and to find that, this is a formula we're considering using. Instead of S of n, n is now infinity. Understand? It tends towards infinite value. So S of infinity is equal to the first term divided by 1 minus r. So these are the three formulas you have to be familiar with in problems involving the sum of a geometric progression. Now, to understand what we have been discussing right from start, let's try to make good use of these formulas. So let's begin. Consider this GP 1 plus 3 plus 9 plus 27 plus ... If, for instance, we are to find the sum of the first 10 terms, what would it be? Now, to find the sum of the first 10 terms, we need the value of the common ratio, likewise the value of the first term. The first term is whatever value begins that series, which is 1 in this case. Common ratio, we know that that's simply the ratio of the second term to that of the first term, or the ratio of the preceding term to the preceding term, where 3 divided by 1 becomes 3. Now, notice that the common ratio is greater than 1. So the formula to use in this case is the first one we discussed earlier, which is a multiplied by r raised to the power of n minus 1 divided by r minus 1. Since n is 10, which is the sum of the first 10 terms, then we can do substitutions. So a is 1 multiplied by r is 3 to the power of 10 minus 1, all divided by 3 minus 1. Now when this one multiply this is gone, so we just left over with 3 to the power of n minus 1, all divided by 3 minus 1 is 2. Now, I will recommend, in case the value of a is not 1, please solve what is within the bracket first, you understand, before you now multiply. Because a is 1 here, that's why I just decided to multiply it, because I know it won't change anything, you understand. So do what is in the bracket first before you multiply. So what exactly is 3 to the power of 10? So s of 10 now will be equals to 3 to the power of 10. I need to use my calculator for that. So I got 59049, and I'm subtracting 1 and dividing my result by 2. So if I do minus my answer minus 1, so that will be 59048 divided by 2. And if I divide it by 2, final answer for the sum of the first 10 times becomes 29,524. So this is our solution to the sum of the first 10 times. And this is how to effectively use the sum of GP formula to find the sum of a certain times, or of some certain times. So let's consider a situation whereby the common ratio is less than 1. So consider this GP 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 plus dot. So let's say, for instance, we have to find the sum of the first 5 terms, in this case s of 5. So just like before, we need the first term and the common ratio. So the first term in this case is 1 also, and the common ratio would be 1 over 3 divided by 1, which is still 1 over 3. Perfect. Now, since the common ratio is less than 1, as you can see that 1/3 is 0.033 and repeating. So it means we are constantly using the second formula. And the formula says that the sum of a GP whose common ratio is less than 1 is expressed as a multiplied by 1 minus r to the power of n, or divided by 1 minus r. So upon substitution, we have the value of a to be 1 times 1 minus common ratio is 1 over 3 to the power of 5, which is the value of n, divided by 1 minus 1/3. So this simply equals to 1 times that, we still have 1 minus 1 over 3 to the power of 5, divided by 1 minus 1/3 gives us 2/3. Perfect. So let's do 1 over 3 raised to the power of 5. So when I type that into my calculator, 3 raised to the power of 5, so I got 243. So this becomes 1 minus 1 over 243 divided by 2 over 3. We can simplify this forward. We can get rid of this right now. So the sum of the GP, or sum of the first 5 terms, becomes, so let's find the LCM of this. If we subtract, let's the LCM with 243. Then 1 and 243 gives us 243 minus 1. Then this division, let's turn into regular, divided by 2 over 3. Perfect. So now we have 243 minus 1, 242, divided by 243. Now let's change the sign to product, then we flip this one upside down. Okay, so we have 3 over 2. So now 243 can be reduced using 3. 243 divided by 3 gives us 81. So 3 here 1, 3 here 81, 2 here 1, 2 into 42, okay, 121. So final answer in this case is 121 over 81. So this is the sum of the first 5 terms of the GP. So that's how to easily find the sum of some certain terms of a particular GP whose common ratio is less than 1. Now, considering this same GP we used to find the sum of the first 5 terms, let's use it to find the sum to infinity of that GP, as that GP is a kind of GP whose common ratio is less than 1. And when the common ratio of any GP is less than 1, we can always find its sum to infinity. Let me write the GP again. We said this in the form 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 plus dot. So the sum to infinity of this GP becomes A divided by 1 minus R. Earlier we said A is 1 and the common ratio is 1/3. So it means the sum to infinity will be 1 minus 1/3 is 2/3. Okay, and if we use the method of keep, change and flip, we have 1 divided by 2/3, which becomes 1 times 3/2. It means the sum to infinity of GP would be 3/2. So that's how to use the sum to infinity formula as well. Now sometimes you might encounter word problems involving this topic, and to interpret it, what are the steps you have to take? So to explain this in the very best possible way, let's try to go over some examples. Example number 1. The sum of the first 2 terms of a GP is 9 and the sum of the first 4 terms is 45. Calculate 2 possible values of the 5th term in the progression. Now, your first question might be, what formula of the GP are you to use? Would it be the one whose common ratio is less than 1, or that of the one whose common ratio is greater than 1? Well, what I would suggest doing in this kind of scenario is that you can just make a test run, or you should just inspect yourself. If that common ratio is going to be less than 1, you understand, there's no way we are going to sum the terms in that GP, whereby at the end of the day we are going to get something like 9. It will rather be a fraction that we are going to get, or we get a negative value. That is if the common ratio is less than 1. Are we together? Do you get where I'm going? Makes sense? There's no way you are going to add those terms and get 45, and not even a larger term, just the first 4 terms and get 45. If that common ratio is less than 1, you know, a value that are less than 1 can either be fractions or negative number. There's no way you can add a negative number, just 4 negative numbers, and add 45. You understand? That's absolutely impossible. So you can either have negative values or you got fractions. So since fractions or negative value is not present, then this is a good indication that the common ratio is greater than 1, and you have to use the sum of GP for R greater than 1. Perfect. So they said the sum of the first 2 terms, S of 2, is 9, and the sum of the first 4 terms, S of 4, is 45. Our goal is to find the possible values for the 5th term. So this simply means the 5th term might be more than 1. But let's see if this is true. Initially, if at all we are not given 9 and 45 as the value of S of 2 and S of 4 respectively, to find them, what we would have done is this. We would have said S of 2 is equal to A multiplied by, since R is greater than 1, that will be R raised to the power 2 minus 1, all divided by R minus 1. So we have used the GP formula for R greater than 1. So that's multiplied by R raised to the power n minus 1 divided by R minus 1. Okay. Now we're going to do the same thing for S of 4. Are we together? Exactly. So therefore, okay, let me get it this first. So for the sum of the first 4 terms, S of 4 becomes A multiplied by R raised to the power 4, then minus 1 divided by R minus 1. Perfect. So the goal now is to find the value of A and the common ratio. Now for this to be possible, let's divide equation 2, which is S of 4, by equation 1, which is S of 2. So let me leave it alone. Let it be equation 1, let it be equation 2. Now S of 4 divided by S of 2 becomes A multiplied by R raised to the power 4 minus 1 divided by R minus 1. Then we have this division. So I've turned this one that is connecting the 2 sums, I've turned into regular one. Okay. Then we have A multiplied by R squared minus 1 divided by R minus 1. Now, clearly you can see that these will cancel at the end of the day. But why does it cancel? Let me try and show it out. Now, if we use the method of keep, change, and flip, we can clearly see that s of 4 divided by s of 2 becomes, keep the first fraction, r raised to power 4 minus 1 divided by r minus 1, then change the sign to product, and you turn this upside down as if you flip it. So that's going to be r minus 1 divided by a multiplied by r squared minus 1. Now clearly you can see that this goes, and the a valued as well. Perfect. So moving on, we now have this as what gives up. So left over is such that s of 4 over s of 2 equals r raised to power 4 minus 1 divided by r squared minus 1. Now, what should we do at this point? Well, this expression right here at the numerator is factorizable. You can see it's a difference between the power of 4 of two numbers. So, 1 can be re-expressed as r raised to power 4 minus 1 raised to power 4. Then we have r squared minus 1. Okay. Now, using the knowledge of difference of two squares, this can be break into r squared minus 1, then multiply by r squared plus 1. Understand? By the time you expand this back, you will end up with this. Then divided by r squared minus 1. So these can cancel. And left over is such that s of 4 over s of 2 equals r squared plus 1. But s of 4 and s of 2 are given as 45 and 9 respectively. So therefore we now have r squared plus 1 to equals to 45 over 9, and r squared plus 1 becomes 5, as 9 in 45 is 5. Now, subtracting 1 from both sides, we have r squared to be equals to 5 minus 1, which is equal to 4. So, upon finding the square root of both sides, we have r squared to be equals to, okay, let me find the square root. R becomes square root of 4, which is plus or minus 2. So that's the value of r. Now, with these two values of r, let's find the common ratio. So you can use any of the equation to get the common ratio. So let's use the first equation. That is when 9 is equal to a multiplied by r raised to power 2 minus 1, all divided by r minus 1. So now r is plus 2. When r is plus 2, what will be the value of a? Let me write the value of r somewhere around here. So r equals plus or minus 2. So the goal is to find the value of a as well. So when r is plus 2, we have 9 to be equals to a multiplied by 2 squared minus 1, or divided by 2 minus 1. So we have 9 to be equals to a multiplied by 4 minus 1, divided by 2 minus 1 is 1. And upon cross multiplication, we have 9 to be equals to a multiplied by 4 minus 1 is 3. And upon dividing 2 by 3, a becomes 3. So that's when r is 2. Now when r is minus 2, what would have happened? Let's do that again. Don't forget the equation we are using is such that 9 is equal to a multiplied by r raised to power n minus 1, which is r raised to power 2 minus 1, divided by r minus 1. So when r is negative now, we have 9 to be equals to a multiplied by minus 2 all squared minus 1, divided by r minus 1, which is 2 minus 1. Or minus 2 minus 1 to say. Minus 2 minus 1, r is minus 2. Upon simplifying forward, we have 9 to be equals to a multiplied by minus 2 squared is 4 minus 1, divided by minus 2 minus 1 is minus 3. And if we cross multiply, we have minus 3 times 9 equals to 4 minus 1 is 3a times 3. So 3a becomes minus 27, as 7 times 3 is 27. So eventually a becomes minus 9. By the time we divide 27 by 3. So that's the value of a when r is minus 2. So a is 3 and minus 9. Okay, now for you to be mixing this up, let me write it in this manner. When r is plus 2, a is equal to 3. When r is minus 2, a equals minus 9. Perfect. Now these are the two values we use to find the fifth term. So the possible values of the fifth term, that's u of 5. The general term of a GP is defined such that u of n is equal to ar to the power of n minus 1. So this simply means u of 5 would be equals to ar to the power of 5 minus 1, which is 4. So we said a is 3 when r is 2 raised to the power of 4. And that becomes 3 times 2 to the power of 4 is 16. And multiply this, we have 48. So that is u of 5 when r and a are positive. Now u of 5 when r and a are negative, we have the value of a, which is minus 9, multiplied by r, which is minus 2 to the power of 4. We have minus 9 times minus 2 to the power of 4 is 16. We'll multiply with minus 9, then we should get negative 144. So this is the second value of the fifth term. And that gives us the solution to this example number 1. And hopefully you understand it and you follow up with the process. So as we understand them more better, let's consider some more examples. On to example number 2. The second term of a GP is 24, and its sum to infinity is 100. Find the two possible values of the common ratio and the corresponding first term. So by the way, if you want to try this question, feel free to pause the video and figure it out. And after that, you can unpause it and see if you have done the right thing. Also, if you haven't subscribed to the channel, feel free to hit that subscribe button. And also you can give a like or a good comment if you are finding the video helpful. So let's proceed. So the second term is 24. That's the number of term. And we say u of n is ar to the power of n minus 1. So we are given u of 2, which is the second term. So that's when n is equal to 2. And that will be ar raised to the power 2 minus 1, which is ar raised to the power 1, which is the same thing as ar. So let's keep that aside. Let's say its sum to infinity is 100. That is s sub infinity, which is equal to a divided by 1 minus r. Let's say this s sub infinity is equal to 100. And we have to find the possible value of the common ratio and the corresponding first terms. So we have two equations we can use to set up an equations or system of equations in order to get the value of a and r. This u of 2, don't forget, is given as 24. So we have this one and this one. So let's simplify the second one first. If a over 1 minus r is equal to 100, then can we cross multiply? Upon cross multiplying, we have a to be equal to 100 multiplied by 1 minus r. And upon expansion, we have a to be equal to 100 minus 100r. Now, since a is equal to 100 minus 100r, let's try and name this equation. Okay, if this one is equation 1, let this be equation 2, and let's be equation 3. So in equation 1, let's put a equals 100 minus 100r. Since equation 1 says that ar is equal to 24, as we are following the steps, then if we substitute 100 minus 100r, we have 100 minus 100r multiplied by r equals 24. Now let's expand. 100 times r is 100r minus 100 times r. 100r times r is minus 100r squared equals 24. And let's set this equation to be equal to 0. Then we have, let's bring this and this all the way to the side. We want to work with positive. Then we have 100r squared minus 100r plus 24 equals 0. Now let's reduce the fraction a little bit in order to solve for the value of r. So therefore, if we divide through by 4, then we would have 100r squared divided by 4 minus 100r divided by 4 plus 24 divided by 4 equals 0. So 4 in 100 gives us 25r squared minus same thing applies to this 25r plus 24 divided by 4, that will give us 6 equals 0. Perfect. Now let's factorize. We need two numbers that multiplies to 25 times 6. And at the same time, we add up to minus 25. So what are these two numbers? Can we use 15 and 10? 25 times 6 gives us 150. And if we break 150 to 2, we can have 15 and 10. And 15 plus 10, if we assign minus to both of them, we should get minus 25. If we multiply, we should end up with 150. So 15 and 10 is best to use. So therefore, we now have 25r squared. So let's replace the middle term. Minus 15r minus 10r plus 6 equals 0. Now when we group this, we have 25r squared minus 15r in parentheses. Then in the bracket again, minus 10r plus 6 equals 0. Now, for this one, let's factor out 5. If we bring out 5, we have 5. Okay, let's do 5r. We have 5r minus 3. And for this one, if we do minus 2, we have 5r again minus 3 equals 0. So we can combine this and take the GCF. Now we have 5r minus 2 multiplied by 5r minus 3 equals 0. This is r, not 6. So we can set both of them to be 0. 5r minus 2 is equal to 0, and 5r minus 3 is also equal to 0. So upon solving for r, we can have r to be 2 over 5 and 3 over 5. So these are the two possible values of r. Next is to find the possible values of the first time. So we're considering using equation 3 we named earlier. If you could recall, we said equation 3 is such that a is equal to 100 minus 100r. So therefore, when r is 2 over 5, we have 100 minus 100 times 2 over 5. 5 here 1, 5 here 20, 20 times 5 times 2 to say, becomes 100 minus 40. That gives us 60. So when r is 2 over 5, a is equal to 60. Now, when r is 3/5 or 3 over 5, we have 100 minus 100 times 3 over 5. 5 here 1, 5 here 20, 20 times 3 is 60. We have 100 minus 60, that gives us 40. So these are the two possible values of the first term as well, and that gives us a solution to example number 2. So this is how you can come across problems involving words problem that is related to the sum of a GP, including the infinity. So I hope you find this helpful and understandable. Thanks for watching. See you in the next video. So I have an exercise for you, and here it is. So feel free to share your solution via the comment section below. Bye for now.